Does it work?
Yeah, that's fine.
Oh, okay. Here you can see a photo of my client with her friends, and they are sitting in her toilet. So I would like you to try to spot where is the toilet in this picture. Just try to find out. I don't know if please move this window away. Should I move something? No. Okay. Can you spot my mouse moving on the screen?
Yeah, that's.
Yes, yes. So this is where the toilet is. This toilet has been designed by Dr. Debaldeb. You can see his photo on the right. It's a eco-sanitation, so it's a toilet which creates no black water at all. You don't mix the excreta with any water. Here you can see Linus and Rupsha, who are the owner of this house. You see, again, we are having a small meeting in their toilet. She's drinking coffee. And it is a toilet which has absolutely zero smell and which does not look like a toilet. Here you can see the principle, how it works. You separate the three components, which are, one is excreta. The excreta is treated by dehydration on a vault. The excreta falls through this PVC pipe in this drying vault. The urine is harvested in a small plastic tank from which we can use it for fertilizing the garden. And the gray water is utilized, it's not utilized, it is treated by this root zone treatment. And at the outlet of this root zone, the water, Linus has done some analysis, the water is of bathing quality, means you can use it for a swimming pool, and the outlet goes into the ditch next to the house. So there is zero infiltration of any dirty water into the ground. Because you see the excreta on the left is left above ground. It dries in this basket. After about 6 months, this small basket is filled up. It is pushed on the side, and Linus places a second basket. Like that, you have 3 baskets. So you have about 1 year for complete drying, even after the last piece of fresh excreta has fallen. During this drying process, a lot of decomposition happens. You have oxidation. Even the dung beetle take part of the excreta and use it. So the volume is further reduced. And after such a long time, the excreta is totally sterile, and Linus just throws it in his garden. It becomes a kind of powder, totally odorless and absolutely safe to handle because all the germs are killed. So it's a toilet which creates no pollution, which eliminates manual scavenging, because since the end result is dry matter basically you have 3 end results. On the left you have the dry excreta. Then the urine, it is also germ-free, you can use it. This is a product you can use to fertilize. And here actually on the root zone treatment, the end product is the plant which you trim regularly. So you don't have to empty your septic tank. You don't have to manipulate any dirty or smelly product. Now is a small video to show how it works. You know, so ecosan are quite popular in South India, where you have basically 2 openings. One is for the excreta and one is for washing. Ecosan are a little more complicated in India than in the West, because in India we need to wash with water. So we have a third element to divert. In the design of Dr. Debaldeb, this is solved with one single hole. So you don't need to move yourself. I show you in this video how it works. This is a lever. So here the excreta falls straight. And this is for the urine in front. And you close it when you wash. So the water cannot meet the excreta. So, yes, in this video, another big advantage, which was unexpected, but my client, Ruksha, was so happy about it. She wrote a WhatsApp message to me saying, she wrote, it's so much cleaner. So I asked why? What is cleaner? And she told me, because there is no splashing. You see, there is no bowl, there is no water at the bottom. So your excreta falls straight in the pipe. So you don't need to clean anything, and there is no splashing ever on the side or on your own body. So it is less maintenance, less smell, and hugely less pollution than the normal ecosan. Now I would like to give a small background on the science behind this ecosan. You see, the trees typically have two types of roots. You have the fibrous roots, which are just below the surface, and the tap roots, which go deep generally to get water. The trees are called the master of the soil. The trees, they built the soil on which, can you hear me?
Yeah, we can hear you.
Okay. So this is a typical cross-section of a soil. The fibrous roots are just below the surface of the soil. So a tree is not at all like a mirror view of the foliage. You know, the roots are very different from the foliage. They are about twice the diameter of the foliage. The tap roots are just below the surface, and they act as a kind of filter. Now, in the normal cycle in a forest, the animals eat, they excrete always at the surface of the soil, from where the fungus create humus. Then the bacteria decompose, gives food to the fibrous roots. And because all this happens in the first few inches of soil, below the fibrous roots, you have only pure water. You have no bacteria, no minerals, nothing. So only pure water reaches the aquifer. Now you have something very interesting, the formation of clay. You know that cement is made of lime and clay. So lime, on one hand, comes from the decomposition of the skeleton of animals. So you can say lime is a non-veg part, and clay is a vegetarian part. Clay is actually created by the roots of plants. Because if you grind stones, you can grind from rock to gravel, gravel to sand, sand to silt. But just by erosion and grinding, you can never go get something finer than silt. Clay is obtained only by chemical process, by the acid, which is secreted by the roots of trees and plants. So clay is created at the bottom, at the tap roots. But you have something called the clay humus compound, which is essential to any forest, any farm. It is a source of life. It is the living part of the soil. You need the humus, which is created at the surface, and the clay, which is created deep underground. How these two components will meet? They will meet thanks to termites. So termites are also an absolutely necessary actor to have a healthy soil. In Europe, it is more the worms which create this meeting of the clay and the humus, with thanks to the calcium which they have in their stomach. And in the tropics and in India, it is more the termites. Also, you also have worms. Now, the flush toilet has been invented about 150 years ago. It was invented as a kind of, luxury gadget for the rich, because at that time you did not have pipe water. So you needed servants to bring buckets of water. So if you need one full bucket just to flush your toilet, and someone needs to bring the bucket by hand, you can imagine it was a luxury device. And now everyone has a flush toilet. It has become a kind of standard, although it's extremely new in history. And this flush toilet has created this totally new concept, which is black water. Black water creates hundreds of dead in India every year because of manual scavenging, because when you clean a sewer, technically it is manual scavenging. And we still need people, as long as we have sewer with black water, and probably we will need people to clean these drains. So now I want to show the original design of Dr. Debaldev, which is an extremely simple design. The one I did for my client is a luxury design, and which costs approximately the same as the cost of a septic tank. But this one costs nothing. Here you can make the entire toilet for 2,000 or 3,000 rupees. The only major element is this sliding gutter, this sliding channel. So you sit on this platform, you adjust the gutter so that the urine goes in the gutter, and when you wash yourself, you just pull the gutter behind you, and that's all. And it is a toilet which has absolutely no smell and creates zero pollution. Here I explain some details. You can have the same. Debaldev also has done a model with a commode for people who sometimes prefer a commode. It works all the same. You see, this commode has an inverted slope. It is a cone with the, it is wider towards the bottom. So here it's even better than the one I designed in Baripur. The one I designed in Baripur, it has a pipe because the toilet is at the first floor and the drying vault is at the ground floor. But here it's very simple. The seat is just 2 feet above the drying space. So you have this inverted cone, and the excreta is never going to touch this, never going to touch anything. So you don't need to clean anything. And these are some references for the ecosan. So I want to start with this because it took me a lot of time. You know, I saw this ecosan for the first time, I think in 2005 in the farm of Dr. Debaldev. And it took me a long time to develop something that will work in urban environment, which I did for Baripur. And I think, so this is one of the possible ecosan. You have the South Indian model, which works also very well, but in which you have to move yourself. So, which is, it works all the same, but it's just slightly less comfortable, that's all. So this is really an example of something totally eco-friendly, this ecosan. Now I want to show a little more of this house of Linus and Ruksha. This is a drawing which was done by an artist. This is South Veranda. So it is made of reinforced concrete frame, bamboo frame, brick walls, mud walls. This is the inside view of the top floor. The top floor has a bamboo frame, mud walls, mud floor. These floors are totally made of mud except the steps. Otherwise, the steps would be eroded. This is a wardrobe in the bedroom. So the bedroom is totally made of mud, and even the floor above at the ceiling level, there is a mezzanine. This is made of bamboo and mud. There is about 6 inches of mud on top of this floor. This is a brick staircase in the same house. And this is a bamboo staircase with the same helicoidal design, but made of bamboo. This is a thatch, and the thatch is covered with skylight. And the skylight is a little bit of high-tech because it has, in the same kind of frame, it has a lightning protection. It has a kind of sprinkler system, so that at the time of Diwali, when people use rockets and sky lanterns, they spray water on the thatch as a preventive measure against fire. Yeah, so the thatching was done by one artisans collective called Matachat, based in Bhuj, in Gujarat. And it was done with the local rice of Sundarbans, near Baripur, Dudeshwar rice. And the rest of the house was done by the Raj Mistri, the artisan you see on the left, Paritosh Pore. He is from the Sundarbans. And they built everything from the RCC frame to the bamboo frame, the mud walls, the mud floor, the brick dome, the brick and bamboo staircase, the ferrocement bathtub, the ecosan, the GI bamboo doors. I will show you these doors in the next slide, the GI windows, including all the finishing. This house is also special because the owners assume the role of contractor. So this, because they took this responsibility, you know, they went every day at the site, they purchased the material themselves, they made sure that every worker was paid absolutely on time, twice a week. This has created an extraordinary efficient work atmosphere at the site. And this house is, this project is one of my most successful because the client was so involved in the logistics, also in the design. We took all the design decisions jointly, client and me. And I have also a number of architectural interns who helped with the design and supervision of the construction and helped with the drawings and the model. So it has been a very nice story for all of us. Here, I want to show some pictures. These pictures were taken a few days ago, just after the cyclone Amphan. These pictures were taken the day after Amphan. And on the right, you have a quotation by the owner. She says that all the neighbors, they came to see the house and they expected damage because a thatch and bamboo house is supposed, in the popular wisdom, it's supposed to be weak. And they were very surprised to see that there was no damage at all, except a little bit of damage. You can see the photograph on the top right. There was some erosion in the mud plaster. Only on the outer mud plaster. The inner mud plaster and has no damage at all. And the other wall, so this was the east wall. The west wall you can see on the bottom left has no damage at all. It is also a mud wall. The thatch has no damage. So the lesson is that whatever material you are using, if you build properly, your house will be cyclone proof. Whether you use a steel sheet or thatch or whatever you want to use. We have seen a large number of light steel structure covered with steel and cement fiber sheets, which have been blown away by this cyclone. Now there is something, you know, I started talking, I started mentioning that I started my career in rebellion against modern architecture, and particularly against Le Corbusier. Le Corbusier, when I was a student, was still a kind of hero in France and in my school of architecture. And you see, this is a Villa Savoye. It is a house Le Corbusier built in 1929. And somehow when I was young, I had a deep rejection of this type of architecture. So now you see Le Corbusier in 1927, he wrote what he calls the 5 tenets of modern architecture. Number 1 is building on stilts. So you can see his house is on stilts. Number 2 is a roof terrace, no slope roof. So this is very popular in India because actually you can use the roof for many activities. Number 3 is a free plan. Free plan means you have a frame structure so that the partitioning is not constrained by any load bearing, massive load bearing elements. Number 4 is horizontal windows. So Le Corbusier had a theory that the light is more better quality when windows are horizontal. And the number 5 is free elevation. It means that the skin of the building can be totally detached from the structure. It does not have to carry any load. Now let's come back to the house of Linus and Rupsha. This is something I realized just when I completed the house only. You see, I made a house on stilt. So I have followed the tonnette number 1 of Le Corbusier. I made a roof terrace. You can see here on the top. So number 2, I also follow Le Corbusier. I made a flip plan. You see the top floor, all the columns are slanted.
Laurent, can't see you. Hello?
Yes, yes. Is it working now?
We can't see you, Laurent, and neither the screen share.
It is written you are screen sharing. Okay, new. Can you even now you can see me?
No, I think you can.
I can hear you. Okay, I'm trying. I am needing stop share. I am. Can you see me? Can you see me?
Just a moment. I think Laurent has rejoined, so just give us a moment to fix this issue. Yeah, Laurent, we can hear you,
okay,
but we can't see you yet.
Oh, stop my video. Can you see me now?
No, unfortunately. If you can either start sharing your screen, maybe.
Yes. Yes.
That would be.
I'm screen sharing now. Is it working?
I think there is some issue at your end. So I'd request everyone to please give us a moment. We are fixing this issue. Yeah, Laurent, we can hear you and we can see you. Thank you.
Okay. Okay. Actually, I put a different phone for my connection. Maybe it's working better. I'm very sorry for that. After the cyclone, we have some connection problem in Kolkata. It's not yet.
No issue. You can start sharing your screen. Thank you.
Is it sharing now or not?
No, not yet.
Oh. Okay. So. Yes, share screen.
Yeah.
Can you see? Okay.
Over to you.
Okay. So I was saying this is a tonnette 3 of Le Corbusier, a free plan. It means that my columns have their own grid on the plan, and the partitions are turning around. They are not coinciding with the columns. And of course, since the columns are slanted, I had to play around quite a lot. So here you can see the library and how the corner, these slanted columns are at the corner of a wall. This is horizontal windows. So here the reason is very simple. Since I had these slanted columns, if I wanted to have windows in the same plane, my windows would have to be triangular. And a triangular window is extremely difficult to do. So I decided to hang the windows from the roof. They hang from this purlin here. And the seating here is also hanging from purlin. So I have horizontal windows. You can see the bottom left, the horizontal window. And 5 free elevation. Here you can see how the mystery are putting into place a facade element, which is made of bamboo attached to a galvanized window. So all the facade has been attached to that. Now you see at their feet, there is a bamboo and you have steel rods which turn around the bamboo. So these steel rods were cast together with the beam and they protrude out of the beam. We place the bamboo top and then we use the rods and create the support. So the entire facade of this building is just clamped on the concrete frame. So I was quite surprised to see that I started my career now almost 30 years ago on a complete section of Le Corbusier's principles. The house I am most happy with, it turns out that I have been following the principles of Le Corbusier. And so this is something I find very striking and interesting, that we should have the mental flexibility to disassociate sometimes the aesthetics or the accepted form that come along some concept or some words, and to just turn the concept around. Here there is another advantage which Le Corbusier could not see, and I will talk more about this a bit later. This building has been made, first we made the concrete frame without any slab. So that is quite unusual. You see on the left, someone is doing a dome at the top floor. So it is a technique of shallow dome, which has been developed in the last 30 years by master masons from Western Uttar Pradesh and Haryana. These domes are built without shuttering. There is no shuttering, there is no propping, and highly trained artisan can finish a dome in about 10 hours. Here the mistries from West Bengal, I trained them myself. They are not yet experts, so they need 4 days to make a dome. But even if you take 4 days, it is much quicker than a slab. Because a slab, you need 2 days for the shuttering. Then you need at least 1 day for the rod binding. Then 1 day for the concreting. This is minimum. Then you need to wait 7 days for the curing before you can remove the props. So you cannot use a room below for at least 1 week. And normally it's better to wait 2 weeks. And also you have to spray water on the slab on top. So it's difficult to use the floor above. But here with these domes, in the morning of day 5, the room below was free and the room above was free. So we built this entire house, structure, floor, roof, including roofing, in just 3 months. And this was possible because of this technique of shallow domes developed in Western Uttar Pradesh and Haryana. You can see this technique. It's a kind of plug and play technique. You can see the staircase on the right. We decided the location of the staircase after the frame was complete because we were still discussing. And we could just place it anywhere because this type of staircase is plug and play. You do not need to link this staircase with the RCC frame. So this is interesting because this is a point which Le Corbusier could not have foreseen. But this is something which is actually enabled by the reinforced concrete. You see the domes until 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 the shallow domes were invented, a dome meant it was a temple, it was a church, it was a mosque, it was a monument, it was a mansion. Shallow domes. Shallow domes means they are very flat so that you can have a floor on top. But shallow domes were for the rich, for the mansions, because a shallow dome is pushing the walls about 10 times more than its own weight. So you need massive walls. Now, how can we make shallow domes in low-cost, means normal houses? Not these exceptional monuments, but in a normal house, that's the house of Linus and Ruksha. How can we do that? Because of reinforced concrete, we have steel ties that hold the dome horizontally. It is the steel tie confines the dome and absorbs the horizontal reaction of the dome. So these domes are, what makes these domes affordable is actually reinforced concrete. This is another thing which I am trying to promote. These are galvanized steel doors and windows, which are absolutely non-toxic. So you see, when you consider a building to be eco-friendly, you have to consider all the aspects from construction, even mining, construction, people who will live inside, and demolition. Now, if you have a material which do not need painting, you can avoid a significant part of toxic materials because paintings designed for metals prevent corrosion. They emit VOC, volatile organic compounds. Very often, you can see the workers, they don't use brush, they use a cloth, so they touch the paint with their hands, and the paint, the solvent enters in their skin and attacks the liver. So generally, painters do not live very long because of this practice. So if you can avoid MS and use galvanized instead, it is something which is much more eco-friendly. Galvanization is also in itself not a very polluting process. Galvanization. You don't need it. Then it's our job as architects to play with the aesthetics to make this silver finish pleasant. I find that together with bamboo, it works quite well. Here you see you can have a bamboo paneling. So this boy is he's making the paneling, but actually, do you hear? You see, all the work in making strips, all should be the equal size, equal thickness. Then it takes about half an hour to just fill up the panel. Okay, now I would like to to go a little bit into more philosophical thought about architecture. This is a painting by Durant. If you look carefully, you can see some faces, human faces in this painting. There is one which is very obvious, which is looks like an old man looking towards the left, and just below it you can see a round eye with a nose. You can see another face. Then there is another face on the mountain on the left, another one in the field. So what is striking for me in this painting is that the landscape is somehow completely human. And this has deep questions about the idea of nature and the idea of architecture. You know, some years ago, when people asked me what kind of architecture I was doing, I was saying, my answer was, I am doing natural architecture. And then it was a bit of a contradiction. One architect, Professor Satyapakash Varanasi, recently, he observed that we make our buildings from materials taken from nature, but our buildings themselves, they do not belong to nature. So this is a very interesting problem. That's why I prefer to define my work at present as for health. I'm trying to make buildings which are healthy for people who create the construction material, for the builders, for the owners, for any people who will visit, and for people around the house, and also for the demolisher, and also for the animals. Means if you think about health in its true meaning, it has to be a holistic concept. You cannot separate the health of one person from the health of the neighbor of that person or from the health of the earth. This is something, by the way, which has become very, very obvious to us in this time of coronavirus, where we all realize that taking care of our own health is important, has positive consequences for others. So health is not something that can be segregated in small partitions. Now there is, I want to show another picture. This is a drawing by an artist, a drawing of the Alps in France. And there is one non-natural element in this painting. I don't know if you can see it. There is a small village at the bottom left, just under the tree. And this village looks like really belonging to the landscape. And I'm sure we all have this experience of going in a landscape which has not been too much damaged by modernity, and we find that all the houses, even the fields, even the agricultural fields, which are actually artificial, they look like they belong completely to the landscape. Now, this is a quotation by Adolf Loos. Adolf Loos is one of my inspiration for my architecture because of the quality of his buildings. And he wrote some very interesting books. This was written in 1910. So I will read. Adolf Loos says, "Let's have a walk on the shore of a lake in the Alps. The sky is blue, the water green, everything rests in a deep peace. Mountains and clouds are reflected in the water, and also the houses, the farms, and the chapels, which seem to have been made not by humans, but by the same divine workshop as the mountains and the trees, the clouds, and the blue sky. But what is that? A wrong knot disturbs this harmony. Among the peasant houses, a villa throws a displeasing and pointless cry. It is the work of an architect. A good or bad architect? I don't know. I only know there is no peace, no rest, no beauty anymore. How can the work of an architect, good or bad, sully the lake?" Adolf Loos was an architect, of course, and this was a kind of question which he was asking himself in 1910. This is a drawing by the same artist who has done this drawing previously of the mountain, which I feel illustrates the quote by Adolf Loos. This house with all the, it's very funny because it has all the gimmicks of so-called vernacular. You know, it has exposed stone, it has this cast iron cooking pot, some wood, little bit of everything. And his house is so fake, it looks like it's made of plastic. And he's very happy in this landscape. And he says, "I am satisfied. My wish is fulfilled." And for me, this drawing really summarizes in a glance the quotes by Adolf Loos. Now, this is a quote by the same artist. He tells about his village. I will read. "My childhood village, Le Bochet, is in the news. As you know, a landslide is threatening to take away some houses. Let them go. Le Bochet was burnt down at the end of the war. You know, the Second World War. The one that we should hope that humanity will become reasonable and that we'll never see such things. such a brutality, such horrible things. So they did not just burn it like mere Vietnamese huts. They rebuilt it also, the bastards. That's all the consideration they have for childhood memories. Slate roofs and stone walls. The village was a rock within the rocks, invisible from a distance. Everywhere stable doors. One could hear behind each of these the breaths of the mule, the stomping of its feet. Only garage doors now. How silent is a car when it's not running? This is a cartoon by the same artist. It shows the destruction of some houses in a village, which are several hundred years old, in order to build a cultural center. So this also illustrates what Adolf Loos noted. Where is the culture? We are destroying the true culture to make a cultural center. Now this is the drawing by the teacher who taught me most during my studies. Jacques Frédet was running a course called a Knowledge of Building. So this is absolutely extraordinary drawing. Jacques Frédet made probably thousands of such buildings from building all over the world, where he took the dimension of every element and has shown it in its exact place in the drawing. This is a building in Paris, from foundation to the top of the roof. Every element is shown. This is another. It was a 6 months class. We were in groups of 2 or sometimes 3 students, and we had to make a full mother drawing of a building in Paris, showing the complete structural anatomy of the building. And fortunately or unfortunately, I don't know, it was quite easy to find such buildings because demolition was happening, is still happening, of these buildings, and we managed to get permission to enter in these buildings and take measurement and make the drawing. Actually, even if the building is not being demolished, most of the time it is possible to draw the anatomy if the building is not in a perfect shape. You can see many symptoms that betray the structure in the form of cracks, or in the form of shade in the paint, in the form of plaster which is already partly removed. So most of the time you can make out. Now this building is this drawing are absolutely unique because, let's look again at this drawing. This building was built without any drawing originally. And this building does not exist anymore. It has been demolished. So why on earth would someone spend time and energy making such a drawing? Because the building was built without any drawing. It has been demolished. Why would we make a drawing now? This is the answer given by Jacques Frédet. The motivation for this study came when observing that such a work, which has never been done, is about impossible. He's talking about Paris. There were mother drawings of antiquities, of big monuments, but Jacques Frédet was working on the ordinary buildings. Continue reading. Because the true archives in this domain, richer than any attachment to property deed or registration act, are the buildings themselves, testimony of their inhabitants, which have continuously adapted them to their use. And these witnesses, which should be fully questioned, it means scrutinized and drawn from foundation to roof, are disappearing right under our eyes. They block streets, entire neighborhoods, at the rhythm of arbitrary executions which have taken place continuously since the 1970s. Jacques Fredel is writing about Paris and why he spent decades of his life making these drawings. Now he is explained what is the role of the drawing. Some people might feel that vernacular architecture, because it has been traditionally drawing, I mean, it's not relevant to make a drawing. You know, some people believe that it has to be kind of intuitive, and it's not something for which drawings are relevant. So that is again the answer of Jacques Fredel. I am quoting him. Giving such importance to architectural drawings could seem surprising. First, because it is a privileged form of expression of formal architecture. But we are concerned here with ordinary architecture. Secondly, because the widespread use of drawing took place after most of these buildings were built. The concept of architectural type addresses the first point. As a mentally visualized whole, the type plays in ordinary architecture a role similar to that of drawing in formal architecture since the Renaissance. Master mason and master carpenter compensate this absence of drawing with a constant presence at the work site. The second point refers to the art of stone cutting and carpentry joining, the practice of geometric construction. For shop drawings, as distinct from architectural drawings, probably goes back to the beginning of the Gothic period. It is evident in formal and ordinary architecture both. This does not mean that the drawing necessarily comes first and the construction after. The opposite is historically possible, even more likely. It's because arches, walls, and trusses are commonly made that drawing methods are developed to improve these techniques. So it goes in parallel. The art of tracing, ancestor of descriptive geometry, proceeds by parallel projections. Its purpose is exclusively practical, different from the control of visual effects and ornamentation, predominant in perspective. I want to show some mother drawing which I made in India. The latest I made in Uttarakhand. Here you can see two different houses in Uttarakhand, and when I first saw these houses, I had the feeling I had just reached heaven. Because of the harmony of everything. This house was built in 1972. These are inside views. This is a drawing of the main floor. And this is a section. This is a front elevation. A detailed section showing the various elements. So basically, I plans which I learned from Jacques Fredel. What is important if you want to make a mother drawing is try to make it as much as possible at the site itself. Here I was very lucky because the owner of this house was such a nice person. He just offered me a place to sit on his bed. He offered me tea, and I could just look at the environment, make the drawing. And he not only allowed me inside his house to make the drawing, he also treated me as a guest. So it was an absolutely fantastic experience. After that, I sent him this drawing. I gave him a copy, and I am not sure that he finds this drawing very useful. I don't think so, but I hope he's pleased and amused to see that someone took such an interest in his house. His father built his house, and he himself knows how to maintain, and he knows every piece and bit, every element of the construction of his house. This is some suggestion for repair. This is yes, this is a contour line. Just for your information, if one day you need the contour line, it's quite easy to get it from Google Earth. This, I just took it from Google Earth. This is a second house, which is older, which is even more beautiful. I am sitting. So you please notice I am sitting on the floor. I am not sitting on a chair. So this gives you an idea of the scale. The window. So this is the plan of the first floor, the dimension in centimeter. And this is a plan of the basement, where the buffaloes and cows stay. And between the two, you have a very thin wooden floor, which has the advantage that in winter, you get the heat from the animals is transmitted to the humans, which stay above. This is a section and some details. Okay, now I have done a small exercise, which was also taught to me by Professor Jacques Frédet. It is to try to reconstitute the drawing with the smallest number of decisions. So you have to remember that normally in vernacular architecture, people always build in round numbers. You will never find an owner who decide to make a house, a room, which is 11 feet plus 1 inch by 13 feet plus 8 inches. It will always be in round feet number, or at the most 6 inches, but generally it will be in round feet for the size of rooms. Because that is easy to remember. It is easy to give the instruction to the mystery. The mystery can also remember easily what the owner instruction he has given him. So you make a room 11 by 12. That is a kind of decision that people take. So here, you can see the house. This is, so now I am working on the basis of the hypothesis. I am trying to imagine what was the sequence of decision which led to this drawing, which you see here. You see here, looking at this drawing, it's not very easy. You don't see much regularity. There is no symmetry. But still, it's possible to find a series of decisions. So decision number 1, the room length is 17 feet, measured from outside, across the slope. And the room width is 11 feet, measured from inside. Now, it is something which I found in this room, in this house. The measurements along the slope are taken inside, and the measurements across the slope are taken outside. There is a reason for that. I will tell later. Then the width of the wall is determined by the technique. This is the role of the mystery to tell the owner that a wall should be 20 inches or 18 inches, whatever. And the door width, 3 feet 8 inches. This is a standard. This was to allow, this was a standard size of room. So you have the first room. Second stage, the basement has been extended. So here this is a drawing of the basement. The first room, which was built, is on the right towards the top. So they have added one veranda facing the valley and one room on the left. Now this is the minimum number of decisions which I could find, from which we can get this plan as a result. First, you extend the building by 15 feet on the left. Second, you extend in front by 7 feet. And again, the measurement 7 feet is taken from inside. So now I can tell the reason. You see, the land is very, very slopey in Uttarakhand. So it is very steep. So it is a problem to have a very deep house because you cannot find any flat surface. So the houses have a tendency to be narrow and they are across the slope. So it's easy to make a house as long as you want because the slope is approximately, it is across the slope, so it's approximately flat in this direction. But it's not easy to make a deep house because soon you will find that you have a big level problems. Now, why 7 feet? Because it is a minimum you need to place a. So it cannot be less than 7 feet. And if you want to make it more than 7 feet, it becomes difficult because you have to manage a steep slope. That's why the critical dimension is from inside. What is important is to put a bed, so you measure 7 feet from inside. Now in the basement, they have reduced the door width, and this is to allow for superimposition of the first floor. So they have added a little bit of stone on the right side of the door. So from 3.8 inches has become 2 feet 6 inches. And then there are a series of other small decisions, and all are rational. You see, you decide the location of the door of the second room, then the width of the masonry pier on both sides. You have 7 feet on both sides. This is a typical pattern in Interlaken. You have some sort of massive corner, which is probably to help for earthquake security. And then the width of the main door, the width of the window, these are also standard size. And then that's it, everything is decided. So finally, you have 10 design decisions, and the plan on the left is totally decided. And this is a pattern which you find almost everywhere in vernacular architecture. There is no fantasy. There is no arbitrariness. It is extremely rational. And interestingly, these buildings are at the same time very artistic. They are very beautiful. Now I want to give another example, a different kind of survey. This is a very beautiful photograph. It shows the traditional type of Bengali house. This photograph was taken in 1861. And you can find even today similar building, but you will never find such a steep slope. So one day I decided to find the dimensions of this house from the photograph. It is possible by perspective reconstruction. You paste your photograph in AutoCAD, and you just remember how you did the perspective. You know, as architects, we all learn how to make perspective. You just remember the process, and you do the reverse process. So from the photo, you use the plan. You have approximately half the plan. And like that, you can get the plan and the section of this building. So I got, the plinth is 4 feet high. The roof is almost touching the plinth. The roof slope is about 45 degrees, a little less. And the roof has a very, very strong curvature. Here in this drawing, I did a small mistake. I assumed that the walls were made of water and rubber. And I'm almost sure that's really not, because this roof was really a massive roof, quite expensive. And I believe the walls were made of cob, load-bearing mud, like this house. You see, generally rains give a lot of information on the building. Here, just with one photograph, I got a cross-section of the building. This building, I have to explain how this building is in this condition. It is a building in the Sundarbans. I took this photograph 2 months after the Ayla cyclone, which struck in 2009. And so this building had lost part of the thatch roof, and then one wall collapsed because of the rain. Because after the thatch has gone, the wall was struck by the rain. So you can see the frame. It is a mix of bamboo and timber. The frame is extraordinarily weak. It is hardly unbelievable that such a frame even could have a load even during the cyclone. So this illustrates a basic fact that cyclones are a disaster for the poor people who do not have the resources to build a proper house. You see, this house even does not have continuous, these are purlins, rafters. Rafters are made of 2 or 3 pieces of very, very thin, very slender members attached together. And just below, you see a house which is smaller, taken at the same place in the same day, and which suffered only minor damage during the cyclone because the owner had enough resources to build properly. So the lesson here is that to resist a cyclone, the material is not good. The quality of construction is what matters. And to get quality of construction, you need a minimum of resources. You need access to materials. You need a mystery who is reasonably skilled, and then you can have a proper house. And unfortunately, it's not the case everywhere. Okay, now I want to continue on this. I have given a quote by Adolphe Loos, then by this artist, Pierre Fournier. Interestingly, there is a very similar quote by Le Corbusier. Le Corbusier actually had a fascination for vernacular architecture. He wrote, "Building their Kasbah, the Turks had achieved a masterpiece of architecture and urbanism. But the last 50 years of European colonialism have abolished the natural wealth of the surroundings and have petrified, without any remorse, turned into a rocky desert city in which tightly packed houses overlook noisy roads." So when I read this, I was very amused because it is the same Le Corbusier who built Chandigarh, who built all these buildings which personally I don't like at all. And Le Corbusier had this personal fascination for vernacular architecture. And I was really wondering, how could Le Corbusier do the building, which he didn't with this kind of thought? Now, below is a quote by Hassan Fathy, which is even stronger. He says, "We are witnessing a change that is now forcing a complete rupture with the past. Every concept and every value has been reversed." Hassan Fathy was a bit younger than Le Corbusier, quite, at least, I think, 20 or 30 years younger. This is Hassan Fathy. So on the right, there is a quotation from his book, Gourna, A Tale of Two Villages, where this is an excellent advice for any architect, any student of architecture, how to proceed with a project. I don't even feel like reading. I think better you just read yourself. And this book should be a compulsory reading, I think, in second or third year of architecture. Because what Hassan Fathy described in this book, the whole process of doing architecture, is actually an answer to the question by Le Corbusier. Hassan Fathy, in this small quote here, he concludes, "This would be nothing less than a whole new architecture." These are the two books by Hassan Fathy, Gourna, A Tale of Two Villages, and Natural Energy and Vernacular Architecture. Very interesting thinker is Jacques Derrida. Jacques Derrida, maybe you know, has inspired a number of contemporary architects, like Bernard Tschumi, Peter Eisenman, and a few others, with his idea of deconstruction. And very interestingly, Jacques Derrida, after initial interest, he very quickly took a distance from these architects, and he told them essentially that what they're trying to do had nothing to do with what he had in mind when he thought about deconstruction. And he was extremely clear about that. Now what I find, so this I am sharing with you, it is still a little in the process of elaboration, but I believe that what Hassan Fathy has done in architecture is exactly what Jacques Derrida has done in philosophy, deconstruction. And I will show you how I went to this conclusion. It is by reading this book by this philosopher from Israel, Yeshayahu Ben Aharon. Yeshayahu Ben Aharon says the same thing as Hassan Fatih. He says that modernity has operated a reversal of every value and every notion of the past. And what Ben Aharon says, he says we must reverse the reversal. And this is actually what Hassan Fatih has done. If you read his book, Gourna, A Tale of Two Villages, this is exactly what he has done. He has done a conscious reversal of the reversal. Like modernity is an unconscious reversal of tradition, and Hassan Fatih has done a conscious reversal. There is an architect, Durganan Balsavar. He says something also a little bit similar along these lines. He says that somehow the architect should keep aside his architectural principles in order to do genuine architecture. He has his own words, his own way of saying, but there is a strong similarity. And another architect with his team, Sandeep Vermani in the National Foundation, I believe also has a close proximity with the thought of Hassan Fatih, Jacques Derrida, Durganan Balsavar. And Sandeep Vermani, he kind of compares classical architecture and on the other side, the folk architecture. Folk architecture, some people would call it vernacular. My teacher, Jacques Fredé, would call it ordinary. But clearly, it is the same thing which they have in mind. So in the folk architecture, according to Sandeep Vermani, what is the most important is a process. And this is also what Fatih described in his book, Gourna, A Tale of Two Villages. Hassan Fatih actually pushes aside all the architectural principles that he has learned as an architect. He rebuilds these principles through a process, working with the villagers, with the artisan, and with everyone involved. He rebuilds the principles from scratch. And this is actually the process which Jacques Derrida calls deconstruction. So there is really thought movement going on between architecture, philosophy, and various people. They have their own way, their own words of explaining. And so here I have shared with you some of the ideas and concepts which help me figure out what is, how I am trying to work. Now I would like to talk a little bit about the structure aspect. You have seen this photo by Samuel Bourne. This shape of roof is called in Bengali the dochara. Dochara means two slope, which is very peculiar, strong, double curvature. Now you have these terracotta temples, and they have exactly the same slope. And the structure is totally different. This is a bamboo structure, and this is a brick masonry structure. These two materials, as per what I learned as an architect in my school of architecture, these two materials belong in a completely, behave in a totally different manner. And logically, they should result in a totally different shapes. But actually, it is not so. And you can have a shape which works equally well with two materials which are absolutely different from each other. This is a detail of construction. It is a partially restored temple in Bankura, which is restored in such a manner that you can see the construction process. And you can see the dome, the photograph on the left. You can see the dome was built with terracotta tiles, which are very flat, to enable the construction without shuttering, because the large area of the tile was helping the tile to stay in place without shuttering. And then this is an extraordinary building made of steel, which is a kind of series of dochara. This building was designed by the Russian engineer. It became immediately, 120 years ago, it immediately extremely famous. And the purpose of this engineer, Shukov, was to create a very stiff structure of a strong curvature, a strong double curvature, using elements which in themselves had a limited curvature. You see, these steel members are I sections, and they have a certain curvature, but when you combine them together in a grid, you multiply both curvature together, and you get what I think we should call a dome, a steel dome, where the elements work predominantly in compression because of the huge stiffness of the structure. And now you can see this bamboo shape also has the same structural properties as the steel grid shell designed by the Russian engineer Shukov. So you can see a lot of similarities between different buildings if you look at them through the prism of structure. Now I want to tell my experience of making an Adobe dome in which I could understand these things a little deeper. This is a photo which was sent to me just yesterday by Dr. Debaldeb. Dr. Debaldeb maintains 1,452 rice varieties in his farm in Orissa. Here you can see each variety on a small plot. So some years ago, we made a building in his farm. This was stone walls, and Dr. Debaldeb did not want to use any concrete. Bamboo was not available nearby, and he did not want to bring bamboo with a truck from 100 kilometers away, so he did not want to use bamboo. Steel was expensive, so there was very limited possibilities to make the roof. So we decided to use Adobe. This was a plan, and to use Adobe domes, the problem was that the walls were too weak to take the lateral pressure. I was faced with this problem. So these are the calculations I did. So I think a structural engineer would find it very naive, because actually this as a out of known formula, which I discovered much later. After having done all this work, I discovered this formula was well known, but this formula actually is used to calculate the stress in the band of reinforcement in concrete. So in a totally different structural domain. I could not find this formula related to domes, unfortunately. So you see, I work from first principle with quite elementary mathematics and geometry. I think this does not go beyond class 10 or 11 students, where I calculated basically how many steel rods I need in a tie on the top of my wall to absorb the stress from the dome. And I found that I needed, you see, this is my plan. I needed only 3 rods of 8 mm to take the horizontal thrust of my dome, which was extremely small amount. I was myself surprised. I did the calculation again and again, and I found that that was enough. And because the quantity was so small, Dr. Debaldeb agreed to compromise with his principles and to put a little bit of concrete, and we call this concrete in homeopathic quantities. Now this is the construction of the dome. You can see in the center the concrete lintel is there, this concrete type. It looks very thick. No, it is thin. You see, you have actually 1 inch of concrete, and on top of that, you have 2 inches of mud, because concrete in a thin, such a thin quantities dries very quickly. So to allow proper curing, it is better to put a lot of liquid mud on top to be sure that it will not dry. Otherwise, it may dry in just 2 hours, and then your concrete will be dead. So you have, it's almost a sheet of paper. You see, 1 inch thick of concrete. Then these are Adobe bricks, which were made locally in the village, and we just place them with a mud mortar. You have to start from the corners. This was my first experience of building an Adobe dome. And I am very grateful to Dr. Debaldet to have given me this opportunity because I had no experience except having read the book by Hassan Fatih. And we decided to start. I did the calculation, and we just did, and we succeeded in making this dome. You see, gradually the corners size increase, and at a point of time, they touch each other. This is another room. You also start from the corner, and then the corner touch each other, and then they get a better support. I am going a little fast because time is short, but you see, you have to be careful that there is no slippage where the brick touches the wall, because if one brick slips, then the one layer will come down. Now you see, this room is interesting because it's a L-shaped room, because it has a staircase right in the middle. So how do you do a dome on an L-shaped room? You have this corner in the middle, which is difficult to do. This is how we did. You see, on the right, we stopped keeping some space. We did not come too close to the corner to be safe. And then we started the vault on the left. The vault on the left has reached the corner. And then we start from the other end of the vault, from the corner. And then this corner gradually reaches the angle, the convex angle, which we cannot build directly. Here we have touched. You see, the corner becomes so big, it has reached the corner. And this was where we stopped earlier. And now we can build this negative curvature corner. You see, it is being built on the left here. So we made this dome in an L-shaped room with a corner which has a negative curvature and without any support. Here the corner is growing. And this is a completed room, showing the corner with a negative curvature. Here you can see we call negative curvature when, like a saddle shape. And this is a completed room. So building this room has given me a huge confidence in the calculation of domes. And after that, okay, no, this is something else. So after I built this Adobe dome, I made other experiments, and thanks to Rationality Foundation, I came across the master artisan who have invented these shallow domes of Uttar Pradesh and Haryana, and I started using these domes. Now this photo shows a dome, a very shallow dome, which is 100 years old, which is in St. Paul Cathedral in Kolkata. This dome was about to collapse because of settlement in foundation, so that's why it has all this support. So we did a leveling of the dome, and these are the contour lines, and with the sections. And now you see I did an analysis of the curvature of the dome, and I find that the dome came down exactly following the pattern of a concrete slab. A concrete slab always breaks following this pattern, creating two triangles and two trapezoids. And the lines in blue are the line of the strongest curvature. So this was very interesting because it shows that a shallow dome and a concrete slab work essentially in the same manner. On the left, you have the collapse mechanism of a concrete slab as per the yield line theory, which is accepted theory today, where the crack starts from the middle. And below, you have the breaking pattern of a shallow dome. It is the same pattern, except that the crack starts from the corner. And this was confirmed by experiments done by Rationality Foundation, I think in 2015, where the cracking at the corners was exactly like this. The corner was broken into small parts and then one big part in between. So now I just want to give some references for the structure. I would encourage every architecture student to go a little deeper into the structure and to do the calculation then yourself. 90% of the calculation are calculation of volume and density. And the most important work, I don't know if it's 90% or 70%, but the most important work is to find the load paths. Where will your force go? This was what my teacher, Bernard Charrue, in second year, taught us. For every project, we had to draw, to show on our drawing where the forces were going. And generally our answer was, but sir, we don't know, we are not engineers, how do we know where is the force going? And he replied, but it's for you to tell, you have to decide. It has to go somewhere. Maybe you don't know where it is going, take a decision, make it go here, but we nowhere. And interestingly, so this was in 1986, very interestingly, this is the design philosophies of the greatest structural engineer who have elaborated all the dominant theories today. From here, I said a number of them, Jacques Riemann. Here actually, I have written the names of the books which are easily available online. Most of them are online, or you can purchase them, Jacques Riemann. Santiago Huerta is an architect and engineer with a huge number of articles on the history of construction. Gerard Kennedy made a fantastic small book available online called Practical Yield Line Design. Jörg Schlecht invented the strut and tie method. Tom made a number of articles, huge number of articles. I don't understand 10% of what he wrote, shame for George Schlecht, but whatever I understood was good enough to give me a lot of confidence in designing my buildings. And for example, Tom Poley has this saying, he says, as an engineer, you have to tell the structure where the forces must go, which is exactly what Bernard Charrue was teaching us when we were in the second year. Now, I would like to show some other details which are not in my in this presentation. How long time do we have? Can you tell me, Mohit? Or
I think 5 more minutes before we get into the Q&A.
Okay. So very quickly. I think I will show this document. So sorry, it's not a PP. I have to share my screen. I share my screen. Yes. Can you see it? Mohit, can you see?
Yeah.
Okay. So this is a staircase I built in 2007, I think. I wanted to make it, this was before my Adobe Dome. I wanted to make a staircase without any concrete, just made of masonry. So this was my my section. And this was a basic calculation I did based on quite elementary mathematics. And so I calculated the reactions and the stress in the brick. And I have shown that to the engineer. At that time, I was not freelance. I was working for an architect, and we had an in-house engineer, and the engineer was not convinced, so he asked me to do more details. So I did this truss line analysis, which is a method which was invented in the 19th century, where you decompose your structure in small elements, you add the load, and you draw where your is going. And this method is possible if you have to tell the structure where the force is going. You have to decide it will go here and there, and then what are the consequences? And you see if it works or not. Please, the limit load So the lift was 2.5 tons. So it was the weight of a small elephant. So I could put a small elephant on my staircase. So after I've done this drawing, the engineer said, okay, go ahead. And so this is another example how structural design, which I did myself because the engineer was not ready to do this work. You know, engineers, they learn these methods, but they generally don't practice because in their professional activity, they do 99% of their work with concrete. And so most engineers will not do this kind of work. So now, after having done this drawing, showing, so the engineer was convinced. He told me, okay, it works, go ahead. And this is a construction. We use brick and cement. So here you see we use cement, but this is not shallow dome. At that time, I did not learn yet the technique of shallow dome. It was a little difficult, but we managed. And we use the shuttering. Today I would use without shuttering because at present I know how to make a shallow dome, but that time we use the shuttering. So we build the masonry staircase on the shuttering. Here I superimpose graphic calculation on the photo. And then this is the end result. So this staircase does not have any rod inside, and this is a finished staircase. So my objective was to get a staircase which would not have a cladding, but where the brick would be the actual structural element. And now, Pratik has asked me to show very briefly the software I am using. So I will show it. It is open somewhere. I have the, yes. To share my screen. Can you see the software? Or Mohit, can you see? Is it working? Can you see?
No, I think we cannot. It's stuck.
Okay, so I am making resume share. Can you see now? Oh, okay, new share. Share. Is it working?
We can only see the staircase.
Only staircase, okay. Okay, I'm closing the staircase. Stop share. Share screen. No. Is it working now?
Yeah.
Okay, okay. So this is a photo I took from the net. It is called the Ctesiphon Arch. It is what remains of a palace, which was at the time the capital of the Iranian Empire, which extended up to Iraq. And this is in Baghdad. So I did the exercise to see if I could calculate the force and the stress in this arch. So I use the same technique which I did by hand of this first line analysis, but this time with software. And you see, you can zoom. So this software is called GeoGebra. You can download it, and you see you can modify the section, and the things get modified on their own. So one area which has a particular surface, and if I multiply by the scale of the building, I get the section. I multiply by the width, and I get the weight. And then there is a vector positioned as a centroid. And then I define what is my reaction on top. My reaction on top I can modify with this one. You see, I change direction. Here it is going out. Here it's also going out. And here my force is too big, and the force is too small. So you have to adjust until you get the proper reaction, which will keep your truss line inside your masonry. This is one possible load path. And then easily you can calculate what is what is the stress in the masonry at different level. And you find that the stress is very interesting. The stress is in exact conformity with the requirement of the National Building Code of India for lime masonry today. So it means that the lime masonry characteristic did not change much in these few thousand years. And it means that it's a good science. I mean, they knew already at that time, and we still agree together. So it's a little short to explain these details. If you read the article by Santiago Huerta, and if you practice yourself, you can also do it. Now, I made this just for fun, but I can tell you I used it in another project to make vaults, and where it was not just for academic purpose. From this calculation, I got the confidence that it could be built, that it could be strong, and I could also improve the section. I had to modify the staircase because it was not working well. Thanks to this calculation, I could prove it. Is it possible to show one more document?
Laurent, I think we are running out of time. So if we can start with the Q&A. We have limited time for the webinar on the platform.
Oh, all right. So let's, yes,
thank you. Thank you for your talk. I invite Professor Bhanu Pratap to moderate the Q&A.
I think, Laurent, if you have something, a last couple of slides, you can just quickly go through them. That's okay.
Okay. So I am opening them. It is here. Open and two. So share screen. Share screen. It is. Where is? Yes, this one. Can you see it? Hello, can you see the document?
Yeah, we can see.
Okay. So this is a building I did in Uttar Pradesh in 2003 or 4, which I without any concrete and without any steel. Eventually, I used a little bit of steel. I used one steel rod of 16 mm, which you can see here, which is a kind of tie turning around the building. So this is a plan of the building, the classroom, and the roof is made of 4 arches intersecting together, which have 4.5 meters span. And this is a section, and this is an inside view showing these 4 arches. And the inspiration for this building came from these churches from Armenia, and many of them have intersecting arches. So, what the main thing I wanted to show you is this. You see here, I did a full-scale drawing. The scale is 1:1. I traced with a lime and brush, taking measurements, my arch, and using a rope which was wet so that it would be heavy, and showing the brick at the actual scale. So this is a chainette. It is a natural shape of a hanging chain. So here I got my shape without any computer. That time I had no laptop, and even it was not possible to have a computer in this village because the current was not reliable. So how did I make sure that the resultant was within was falling properly on the foundation? You see on the right, upper right of the photo, there is a rectangle. This is a view of the wall in diagonal, means following the same cutting plane as the arch. And I just extended the same catenary. I just extended the rope, and I found that the resultant is falling right in the middle of my wall, so it was perfectly stable. So actually, I do not need this steel rod, but still I have added in case of earthquake. But for static load, this building is totally stable without any rod. Then I took measurements from this wall, I made this shuttering, and this is the construction of the building. And I show you very quickly. Yes, we used this red sandstone to make the charger. And there are some calculations here, which are quite simple. So sometimes we tell students, don't be afraid to do the calculation. Ask an engineer to help you. And if you have no engineer to help, here it was my case. I was totally alone in this village. That time I did not have internet. And so I calculated the same thing by 3 different methods. And I found the same result. So then I decided to go ahead. This is, yes, the detail of the roof. So this is another example how going a little bit deeper into the calculation can help an architect take decision and can help your design. Thank you. This I want to show also another example. Hello?
Hello. Yeah.
Yes.
Yeah. Thank you for the wonderful presentation, and with the kind of lecture series that we have been through. You know, the previous presenters were talking about digital fabrication, modern technology, modern material use in construction. Probably, I guess yours was the most fascinating for us as well as the students. You know, what we do with our hands. You know, in fact, you have the highest audience so far among all of them. Now I have since we have less time, I have very sort of a couple of quick questions, and I will. There are many questions. I'll just fuse all of them together into 2 or 3 questions. Can you talk about the notion of regionalism and how do you think it is going to either make a comeback, or how is it going to sort of influence? Because a lot of people now are realizing that the past was more intelligent, you know, and
Yes.
there is a lot of possibility of intelligence in how we are evolving, you know, and in evolving also, looking at the future, we think that the references from the past are much more mature than what we have arrived
Yes.
at. So
Yes.
can you talk about that?
Yes. So very briefly, very frankly, I tell you, I am not interested in regionalism, and I am not interested in the past per se. You see, I am really trying to follow the method of Hassan Fatih, which is a process in which working with the people which you have in front of you right now, not people of the past. Right now, you have real clients, real artisans, real investors, and a real landscape, which did not exist in the past. And how to find practical answers, you will find very often you will find solutions which already existed in the past. So of course, as a aesthetic and emotional feeling, I am fascinated by the masterpieces of the past. Okay, that is one thing. But I cannot go to a client and tell him, I love so much this old castle, which anyway he will never be able to afford because or to build. So this is like my personal story, you know, the building which you love, which inspire you, but yet you have to solve a very practical problem, which is right now. And you see the structural design, which I learned from, is not structural design from the past. It is the latest. And I use software and computer, and even much of the knowledge of masonry today, the latest knowledge on masonry has been evolved from reinforced concrete. So I would say, let's not romanticize the past, and let us be very practical. So I have a personal great admiration for the work of the past, and I think every architect, every person experienced that we are experiencing a loss of knowledge, a lot of wisdom, a loss of I would say actual wealth, maybe increase in GDP, but the actual wealth we are losing. But at the same time, I have to answer today's challenge with today's methods. There is no way we can return to the past. So I'm not sure I am very clear. So you see, in my work, I'm trying not to follow too many principles. I'm trying to be as honest as possible with the client and with the people around me, and how we can solve our problem. And this is where this concept of health is important, because you cannot make a healthy building at the cost of the health of the workers, or at the cost of the health of the aquifer, which will pollute the groundwater, pollute your neighbor, and eventually pollute you also. So health is a very unifying concept, also related to honesty. Your building has to be honest. It has to be healthy in all its parts. So, yes, sorry, I'm not sure if this has answered your question.
I mean, in a way, you have put you put a light upon a lot of inquiries that are coming to you as a question. In general, sort of your answer encompasses a hint or a direction, you know, in terms of answering these questions that people have got. Probably now, you know, it's up to them to sort of, you know, how does, or maybe how does one sort of takes the answer that you, I mean, the answer is not just what you're saying right now. The answer also comes from the entire presentation.
Okay. Okay. So maybe if some people are not satisfied with my answer, they can ask further question.
Yeah. So there are other things. If you can talk about, let me just. There's another interesting question. What do you mean by liberation through structure that you mentioned?
Yes. I would have liked to develop more, but okay. So what I wanted to say is that I would never have been able to build what I built if I did not go myself into the details of calculations, because this is where I got the confidence that I could do it. And so this is where structural design can really empower you as an architect to do what you really want to do. And structural design is actually design. It's not just a calculation. It's not just an equation. It's actually a series of decisions, exactly like architectural design. So you have the same freedom in structural design and in architectural design. And so it was a little short, actually, to explain this in detail. If we had 1 hour more, we could have done into the actual figures, how we get how much stress, how much force. And you see, for example, this Adobe Dome. I never built Adobe Dome. I have some photograph from Hassan Fatih, but then I had to decide if it was possible or not, what should be the rise, how many steel rods to put in the concrete. And this was the difference between something that was buildable or not buildable.
So do you also you have sort of developed now this intuitive process, which I mean, intuition is
yes. So I would say it's not purely intuitive. When I built this Adobe Dome, it was extremely intuitive, and this construction understands a lot about how a dome works, following which I again developed the shallow domes. So it was between intuition and zero. It's always an alternate. It's really like you make a drawing, then you verify if your drawing works, then you improve drawing, so it's a spiral process. Yes. Sorry, I think I stopped your question. You had another.
Yeah, I mean, it was. I think you've already answered. You understood the question that I was going to ask, anyways, and you've answered it. Again, I'm combining a couple of questions together, and something that I'd read about
Yes.
About you, that you say the notion that the vernacular and tradition is more equated now with poverty. How do you think the revival of this? I mean, since you're an architect, a practicing architect who is sort of
Okay.
starting. Let me, Laurent, just let me finish the question, because there are a couple of questions here.
Yes.
I mean, how do you see the revival of this happening, both in terms of the construction technique and the material coming back, people adopting these methods, and also I mean, also breaking away with the notion of, as I said before, the notion of poverty associated with
Yes. Okay. Okay. So two practical examples. One is, I am so happy with this house built for Linus and Russia because of this excellent relationship which we had between the owner, Linus and Russia, myself, and the artisans. So this is the way to go. I'm not. I don't. Fatih says you can make quality architecture if you develop a very close relationship with the client. Which, by the way, is very funny because Hassan Fatih quotes Le Corbusier, and Le Corbusier was very contemptuous of his clients. Very, very contemptuous. Whether they were rich or poor or state, or basically for Le Corbusier, every client was an idiot. And poor Le Corbusier was forced to teach architecture how to respect his work. So it's very funny. And Hassan Fatih says the client must be at the center of the project. Now, of course, this has also a consequence. You cannot make a good building if the client is not good. You cannot, yes?
Yeah,
yes.
But Hassan Fatih was more working more on the housing projects and government projects.
Yes. See, everything depends on the client. Now, you can have a good building if you have a good client and a bad architect. You cannot have a good building if you have a good architect and a bad client, because eventually everything depends on the client. So we are in a situation as architects globally where everything does not depend on us. we have to contribute to a situation where everyone, architect, engineer, client, artisan, everyone is in a best position to collaborate in a more constructive way. So as architect, we have our bit to do, but we cannot alone solve this problem. It's absolutely impossible. And about poverty, you see, this ecosan is something which I have a lot of difficulty to get accepted by people. That's why I decided, and I was very happy that Linus and Ruksha accepted, I decided to make a luxury ecosan. Because if you make something which is low cost, and if you convince poor people to use it, they will think that you are doing something for the poor. It means something substandard. And since ecosan is such a new concept, I insist now to make luxury ecosan, where the client will feel the personal advantage in terms of comfort and hygiene. Mm-hmm. And the eco-friendly aspect is just like an additional advantage. And actually the technique is extremely simple. So it's very easy to make it cheap. But I don't want to make it cheap as a strategy to get it accepted. Any artisan can make the same ecosan which I did for 1/10 of the cost. Let him do it. Let him do it 10 times cheaper and do it for him and for his neighbor. But as an architect, also my role is more to actually, in a sense, you know, it's not a bad strategy to work for the rich. You see, for example, I am doing an auditorium in Park Street in Kolkata, in which bamboo and mud artisans from the Sundarbans are working. And they are making money by making this auditorium in the core of Kolkata using mud and bamboo. So this is a way to help these people showcase their skill and also to earn money. And somehow I am maybe more useful as an architect in facilitating this work than designing something for the poor, which very often they can design better than me, given a set of resources. So we have to consider these various aspects where consider, as architects, we depend totally on the artisans, on the workers. It is also our responsibility to establish a very respectful relationship because I learned a lot from the artisan and I could not have been able to learn so much if I had not spent so much time on site.
Yeah, Laurent, I think the connection is getting poor. We sort of missed out on what you said in the end. But I think we'll have to sort of Mohit is pushing me through messages that it's time to sort of, we are going to run off. The webinar is going to shut down any second now. So I would like to thank you and all the participants for joining Intersection Foundation, and especially thanks to you, Laurent. I hope that it's just the beginning of a collaboration, and we'll see you more in the future. Probably we'll engage with you in other modalities if things improve.
Yes, looking forward. And thank you to have organized this. Yeah. Thank you to everyone. Thank you.
Thank you.